Hello students. In lesson number 2, we were talking about the salts, right? And we have learned some preparations and uses of some of the salts. The last one was the washing soda. The chemical formula for the washing soda is Na2CO3 into 10H2O, that is the sodium carbonate. So this sodium carbonate, the chemical formula you can see here, instead of Na2CO3 here, with that into 10H2O, it means that 10 water molecule are attached with the Na2CO3 molecule. So what is the meaning of this? Does this make the sodium, that means the sodium carbonate wet due to this water molecule? And if it is a solid, then in that solid form, these water molecules are present, or if these water molecules are present, then it convert into a solution form. These are the questions arises. So, not just this Na2CO3, sodium carbonate, with that, some other crystals are also there, like copper sulfate, ferrous sulfate, then calcium sulfate, and with that, this sodium carbonate, there are many crystal salts which are in a crystal form. They contain water molecules attached with it in a solid form also, and it is called the it is in the crystallization process. See, these salts are in a crystal form. Crystal means, let me give you some basic idea that crystal means the arrangement of atoms, the arrangement of molecules in the crystal is very periodic and very well mannered. Okay, it's not a random arrangement of atoms and molecules. Very well mannered periodic arrangement of molecules are seen in a crystal. Okay, the distance between the molecules and atoms are also very fixed. So during this crystallization, so some salts are in a crystal form, like NaCl is also in a crystal form. But out of that, some of the salts contain this water molecules attached with it. Okay, the crystals forms, how the crystal form, first of all. When any solution or any solid solution is heated, and that solution is heated so that the water molecule can be evaporated. During that, and then it is cooled, right? So during the cooling process, some of the water molecules are attached with the salt molecule during the cooling process, and this cooling process is very, very slow, so that each and every molecule arrange in a periodic manner, a very definite pattern. Okay, and this pattern we are calling it crystal. Okay, and this during the cooling, the salts having a crystal arrangement, and in that arrangement, during that cooling process, the water molecules are attaching with it. So, and this water molecules are not making crystal wet. Due to this water molecule, it doesn't convert into what we can say solution form. Okay, it is still in a solid form, but this one molecules are hidden inside the solid crystal. We can prove this, that water is present in the crystal by this small activity. We are heating a copper sulfate crystal. Copper sulfate crystal is a blue colored crystal. And this copper sulfate, when it is heated in a test tube, the solid copper sulfate crystals, blue colored crystals are heated in a test tube. Then, due to the heating, the water molecule present inside this crystal's copper sulfate, this water molecule will be evaporated. They are attached, but with a very weak force. So, as we are heating this water molecule will be evaporated. So, due to the heating, water is evaporating. Now, water vapor will rise in a test tube. As it rise above in the test tube, it cools down. Due to this, then at some distance, The water vapor cools down and it will be condensed at the surface of the test tube, and we can see the water droplets are present in the upper portion of the test tube. So from where this water comes? Okay, we have taken a solid copper sulfate, and by evaporation water droplets are seen in a test tube. This clearly proves that water is present inside a crystal, and as the water is removed from by the evaporation process by heating, the color of the crystal changes. It means it simply changes some properties of the crystal. Okay, like which property? Some physical properties like appearance, color changes from blue to white. Then water molecules are removed, so we can say that density is decreased. Density is changed. Okay, so some of the physical properties is changed when the water molecules are removed. So this water molecules, water droplets are seen on the upper portion of the test tube. This proves that water molecules are present in a solid copper sulfate crystal. So all the salts which have water inside it, uh, this means that during the crystallization process, water molecules are attached with it. It doesn't make, we cannot see it by touching, it doesn't look wet, okay? Because water molecules are is hidden inside the crystal, okay? So this water, and by this we can define a water of crystallization. What is water of crystallization? A fixed number of water molecules present in one formula unit mass of salt. Okay, we can know what is one formula. We know that what is one formula unit mass. Okay, in a one formula unit mass of salt, the number of water molecule present in that salt, that is called the water of crystallization. Okay, so where every salt have a very fixed number of water of crystallization, that doesn't change, right? So copper sulfate CuSO4 into 5H2O. The water of crystallization is a fixed number. Okay, in every salt the number is fixed. Like in copper sulfate, it is 5H2O molecule. So the formula becomes CuSO4 into 5H2O. Then a rust, that is oxide of iron, Fe2O3 into 3H2O. But this number of water molecule varies. Okay. So Fe2O3 into 3H. Sometimes it is written that Fe2O3 into XH2O, because this X can be anything. Okay, the number of crystallization is varying in this rust. Then calcium CaSO4 into 2H2O, calcium sulfate into 2H2O. This salt has a common name, gypsum. And in washing soda it is Na2CO3 into 10H2O, sodium carbonate, uh, we can say into 10H2O. That is a washing soda crystal. So this salts have a fixed number of water molecules, and this fixed number of water molecules is called water of crystallization. When salt is heated, this water is evaporating, and when you mix this water again in the let us say in copper sulfate, when this water is evaporating, then when we add water to this white colored copper sulfate, then again it gains its original blue color. Okay, so when this water is added, again that water molecule which were evaporated, now it again joined with the salt molecules. Okay, so again it becomes copper sulfate into 5H2O. Now this gypsum, understand this, calcium sulfate into 2H2O. It has one very specific use. This gypsum is used to make plaster of Paris. The name, in short, it is written as POP. We know that plaster of Paris is used in to support the fractured bones, and also in the ceiling and to plaster the ceiling and walls, etc. So these are the two main uses of plaster of Paris. This plaster of Paris is made from this gypsum. So when this calcium sulfate into 2H2O, this gypsum salt, is heated at 100 degrees Celsius, that is 370 Kelvin Celsius. Then this gypsum is heated. By heating, the water molecule will be evaporating. So calcium sulfate, out of two water molecule, 1.5 of the water molecule will be evaporating. So it becomes calcium sulfate into half H2O plus 1.5 water molecule is evaporated. So this one, CaSO4 into half H2O, that is known as plaster of Paris, POP. This is used. This is a very hard substance after when the water is evaporated. So this is used as in supporting the fractured bones and also in ceiling and in the ceiling and walls, to plaster the ceiling and walls. This one. Now you can ask, there is one question that how half molecule can be attached. Okay, what is the meaning of half molecule? But remember, half molecule, it means that calcium sulfate and there is another calcium sulfate molecule. In between the two calcium sulfate, one water molecule will be shared. Do you understand this? Two calcium sulfate molecule, that is one CaSO4 and another CaSO4. In between these two CaSO4 molecule, one H2O molecule will be attached with both the calcium sulfate. Okay, it means that one water molecule will be shared by the two calcium sulfate molecule. So for every calcium sulfate there is half water molecule available. So this is the meaning of this calcium sulfate into half H2O. Molecule is not divided into half. Okay, that's not, then it will not be the molecule. So calcium sulfate into half H2O and 1.5 water molecule will be evaporating. It means out of the total water molecule, 1.5 times the water molecule amount of we can say 1.5 amount of water molecule will be evaporated, and the fourth part will be remain in the crystal attached with calcium sulfate molecule. This is POP, and it is a reversible process. When calcium sulfate into half H2O, that is POP. When water is added to it, it gives calcium sulfate into 2H2O. Again, we can get the gypsum. Okay. So this is a very simple preparation of plaster of Paris and uses of it, how it is made and where it is used. Very simple. One question can be asked that why it is called plaster of Paris. Okay, if we predict that it may be obtained from Paris, then it is true. Plaster of Paris was earlier, it was obtained from one of the village of Paris, and this is a very special kind of plastering material that one king was using this to plaster the walls of his palace. And then after, it was very good quality, and then after it was used worldwide. So, but still it is known as plaster of Paris. So this was about the whole lesson of acid, base and salt. Write the in-text question answers and exercise question answers, and still if you have any doubt in any question, you can ask me. Thank you.